Oh, okay. Is this? Okay. Okay, it's off. Okay, let's start it. Good afternoon. This is Passaware Network and Research Group. I hope you are in the right room. Anyway, please stay. I'm Jen, and Brian could not be this time with us, so I'm going to run this show alone. So, before we actually started, okay, this is Note Well, which you probably have seen many times this week already. And before we can actually start, I need 2 volunteers. We need the minutes taker and Jabber scribe, please. We really cannot start until we find those 2 victims. I'm sorry. Ale, thank you very much. And for meetings, minutes? Oh, come on. You can just listen to the audio stream after and just write it down. Okay, next time I'll allocate 10 minutes for this. No volunteers. That's really bad. Oh, thank you very much. Okay, the hardest part is done for me. So, now agenda for today. We have 3 presentations. If any last minute agenda question, anyone has brilliant ideas to discuss? No, okay. So what actually been happening in the group, just to remind you, since last IETF, I think Brian posted updated version of his open questions draft. No, actually, I don't think any major changes has been done. I think the document is a pretty good shape, but so I think we can discuss it next time when Brian will be back. So Spencer document about what we should not be doing or what we have done and should not be doing anymore has been adopted. Well done. And we have another individual draft from Teresa, which she is going to present, right, with her cursor. So please, let me change the slides. Yeah. You want a clicker, probably? No? Or you can just tell me.
So, hi everyone. So, hi everyone. My name is Cyril Krenbühl from ETH Zurich, and today Teresa Enghart and I will present the draft we wrote about the vocabulary of path properties. So this document addresses the first question of the questions draft, which is how are path properties defined and represented? So a path property is a characteristic of a path between two endpoints. And what we do in this draft is we list useful and relevant path properties, and then we classify them into three categories. And the classification is mainly based on the spatiality. So how close to the endpoints does this path property show itself? And the temporality, the usefulness of such a measurement over time. So we separate into three different categories, as I said before, into domain properties, backbone properties, and dynamic properties. And I will start with the first two. So domain properties are properties that relate to characteristic within the administrative domain of the endpoint. So they're usually within the first few hops of a path. For example, the home Wi-Fi network or the Wi-Fi combined with the internet Ethernet link to the provider or the cellular network in case of a cellular connection. And these properties are strongly influenced by an endpoint. For example, you can upgrade your data plan to get a higher bandwidth on your Ethernet. Or you can maybe move closer to your access point. Or you can switch to another provider altogether. And for these properties, we usually have a high amount of information. For example, relating configuration, we can use provisioning domains to retrieve information about the local administrative domain. Examples of these properties are the access technology of an endpoint and the monetary costs. Now for the backbone properties, temporality-wise, it's similar to domain properties, so these are rather static. They usually don't change over the lifetime of a connection. So if you have a certain device, for example, a NAT or a firewall, it will not magically disappear within a connection. But backbone properties are not within the administrative domain of an endpoint, so we have less influence on it. For example, if we look at the paths in the backbone of the internet, that the links that our path takes in the backbone of the internet, we usually have no idea where it is. Sometimes if we have MPLS labels, we can sort of know about it, but it's not guaranteed. And these properties change whenever the route changes, which mean it can be order of hours or days or something like this. And examples of these properties are the maximum transmission unit, which is usually not restricted by the local domain, but rather by the links in between. And the list of features or protocols that are available. For example, a path might allow UDP, it might allow large UDP packets, might support ECN or not support ECN, or might block quick packets or allow them. And the presence of certain devices, for example, a carrier-grade NAT, is also a backbone property.
Hi,
Yeah.
Lars, so I didn't see it in your slides, I didn't see it in the draft. What's your definition of a path?
So a path is a set of links and devices that the packet traverses from one endpoint to another. Or links could also be like wireless.
So the scope of a path is during the lifetime of a packet? So paths on the internet change, right? Is what I'm trying to get to. And this sounds like you assume that a path is stable for some time or ever.
Some parts of the paths are stable, right?
Right. That's what. So define for me what you mean by path.
Yeah, I guess the list of links and devices that the packet traverses. So it's
so each packet has a path associated with it.
Yes.
Okay.
So of course, if you have your mobile device and you switch from Wi-Fi to 3G, the path changes, right? It's a different access.
So if a path has meaning for a single packet, right, then nothing is dynamic. So in other words, so to zoom out, right? I think before you can tell me about what path properties are, you need to tell me what a path is in your mind.
Yeah, I see your point. Yes.
Right.
Yeah, sure. Maybe we can discuss this afterwards, after we see all the slides, because the next properties are quite different.
Okay, so let me move on to the dynamic properties, which are mostly end-to-end. So they are not, or usually not applied to either like only the local domain or only the backbone. And what they all have in common is that we expect them to change very frequently on the time scale of, say, milliseconds. And so they are sort of harder to pin down, and we can probably measure them either at the endpoint or on the path with a spin bit, yay, for example. No, we do not like we probably generate some samples of those properties, and then at various points in time at which we think it would be useful to know them, we can like have a median or the minimum of this metric of this property, or maybe also we can only approximate it. We just have to live with that we can't know the actual like ground truth for this property, but we have a reasonable estimate that would help us, and they are usually uni and bidirectional. I'm going to show examples on the next slide. Do you have a general question to the concept?
Yeah, Rick Taylor. Just a very quick question about, is your intention, so I've done a fair amount of work in the Manet working group about not measuring, but actually going down to the layers below, going down to layer 1, layer 2, and actually letting the per link technology tell the higher layers, this is what's actually happening. You know,
yes.
So
we are not necessarily measuring them at the, let's say, transport layer end to end, but we can also have measurements in the physical layer. For example, that's going to be on the next slide.
Okay.
So that is usually within the scope of a connection. We have a round trip time and a round trip time variation, for example, and that is obviously useful. So then we can also have an available bandwidth end to end both in the upstream and in the downstream direction. So here that's an obvious example of an asymmetric or bidirectional, I'm not sure yet what the best word for that is, property. And this available bandwidth, I would expect it to change very frequently, and it's also sort of hard to know what the exact value of that is, but we can probably approximate it by looking at the throughput of, let's say, a connection that like transfers a lot of data and it maxes out, for example, the congestion window, and then we can sort of approximate what available bandwidth we might have over this path, whether it's 10 megabit per second or 100 megabit per second. And so that is the basic idea. And then there's going to be packet loss in the upstream and downstream direction on the path, and there might be congestion or an indication that there is congestion somewhere on the path, and we might not necessarily know where. And then speaking to the last point, there can also be dynamic properties that are more local, but we still think it makes sense to include them in the dynamic properties, because this wireless signal strength that either my wireless driver can signal to me, or like that I can measure, or the modulation rate, or also the current utilization of the channel is like something that is probably on the very first hop between like my end device and the Wi-Fi access point, for example, but it is heavily correlated, or it has a high influence on the other metrics, such as the round trip time, and that is why we think that those belong in the same category. Comments? on that.
Yeah, Lars, I hate to sort of, so this is like a shopping list of stuff that has to do with paths, right? But sort of, I think you need to have a lot more formalism if you want to talk about these things in any sensible way. I mean, we've done quite a bit of work in IPPM and in BMWG on sort of defining metrics. But it sounds a lot of these things are related to that or even identical. But it's so sort of, I can argue with almost anything that you've presented, but because I can't really get to what your definition of it is, it's kind of not productive to have that discussion, right?
Yeah.
So if you go back to his definition, right, that if a path is a thing that has meaning for a single packet, that's I think a good starting point.
And then this is.
But then what does bandwidth mean, right?
Yeah.
That is something that is a function on a vector of such path measurements that so if you have a framework that you can describe these things, but just like you're doing it now, even in the draft, is not really useful.
Yeah. Okay. So the first step was to just list what we have and to see if that's like something, or if we are like missing something, or like what the general scope is of properties, because we wanted to see like what properties are actually useful and so on. And now probably one of the next steps would be to define it more, say, formally.
I would start with defining a path, and then see if you can define some of your properties in terms of that definition of a path. And if it doesn't work, then iterate, right? And I think that would be actually quite useful to have. But at the moment, you're sort of starting sort of
it's sort of
top
like
down, and it's like just
real definition of we have a certain understanding of that might be what that might be, but more formal definition of the useful things. Corey.
So, Gary Fairhurst, I don't often say this at the IETF, but I used to work with modems. And if I'm designing a modem waveform, nearly everything on that slide can be traded one for another on the next time I send a packet. And modulation rate, I can just change. FEC level, I can change. ARQ level retransmits, I can change. RTT, I can change by changing interleaving depth. I then get packet loss changes, So first comment is, all of these parameters are useful for knowing what happened last time and may tell you nothing about what happens next time you try and transmit because it's a different trade-off. So this is something to think about.
Yeah.
The second thing is, I chair a group that does QoS and multiple queues. If you have multiple classes of things, then what happens in a different class affects what happens in this class. So that trade-off isn't even your trade-off, it's the trade-off what happens with the other traffic that also shares the same modulation and coding world.
Yeah, so we have to define what packets we are looking at.
Yeah, I think this is quite ambitious, but it's really, could be interesting, but you may have to be more abstract in what you actually interpret than what you have here. And the last one, anyone who's worked in this world would hate the word bandwidth here when you think you mean capacity, because bandwidth is the thing that these other things flip. So I really encourage you to use capacity this test. The IETF chooses them interchangeably, but as soon as you start talking about RF stuff, please talk about capacity.
Rick Taylor again. Just following on from the previous comments, which I think were both valuable. I think this is valuable work. I'm not trying to shoot this down at all. But going back to my point about a lot of these per link properties, wireless, going to the signal strength, modulation rate, and the channel utilization. The lower links are doing clever stuff. They're doing predictive stuff. I've spent 8 years working on dynamic link exchange protocol, which is in the MANE working group. That's done as an RFC. That will give layer 3 information it cares about in layer 3 terms, as in data rates, latencies, things like that. So you don't have to try and decode what the link layer is doing with its frequency allocation, with its CDMA, TDMA, and all that kind of stuff, because it's not just 802.11. Wireless links, SATCOM, mesh radio systems, they're very clever. So I really recommend you go and look at not only DLEP, but also the microwave transit link guys have done some very good stuff in CCAM. They've worked with the industry about what data can we get that is useful, and how do we get that in a maintainable way that talks about not what happened just now, but what we are going to be doing for the next n milliseconds, n seconds. So, it's trying to tie into their processing so that we can make predictive things at the higher layers. So value, but there's a lot of engineering's already happened.
So just to make sure I got you right, you're suggesting we make the information on what the lower layers, say the physical, are doing more specific, or are you suggesting
More
we just let them
abstract.
more abstract? So
There are, what I'm suggesting is there has already a lot of good work has happened about getting that link layer information into getting metrics that make sense from an end-to-end perspective from the link layer technology.
okay.
I can absolutely send a pointer to
Yeah,
the mailing
that would
list.
be much appreciated. Also in this draft, we are focusing on what properties to get, and we are not yet at the point at which we talk about how we actually get that, like what a specific implementation that
And
tells us.
we already have published RFCs on these properties are available and this is how you get them.
Okay, okay,
So,
awesome. I would
And it's
appreciate
not the
that.
only technology. So
Yeah,
there's
okay, thank you.
Yeah, Adrian Farrell. I want to apologise. I have read your draft. I think there's good stuff here. In the shopping list sense, you are collecting the shopping list, and that's fine. And as Rick says, we have some work in how you collect the information. You may be missing work in the IETF in how you aggregate that information end to end. You know, we can get piece by piece, but what is the end? Like Lars says, definitions, what is a path? You've also got in there a connection and a route. And I think there was a channel. And many of these terms are used in different areas in the IETF in different ways. And unless you nail that right up front, this is going to be real soup.
Okay,
I'm not sure whether it's potato soup or not, but it's definitely soup.
thanks.
Mayor Kuhlmann, I also want to echo one point Lars brought up, and that is that for network metrics, we have a lot of work in IPPM. And what they usually do, at least the upper three metrics are well defined and well described there. And what they usually do is they have a definition on a per packet basis, basically for packet loss, either the packet is lost or not, right? But they also have definitions for like a set of packets. What is missing, what might be the next step is kind of also what Adrian just said, is bringing this on a flow level and defining what a flow is and what the implications are for.
So we could have different metrics on a flow level and on a per packet.
I don't think it's really a different metric. It's just like
property
applied somehow differently. Yeah.
just to follow on Rick Taylor again, just to follow on from that, the DLEP RFC 8175, for whoever's taking minutes, that we have extensions in progress to allow you to get per QoS queue metrics dynamically from the radio or from the link layer. So it can say, I'm running different, I've been configured for different queues, you're getting different metrics per QoS, or it'll do it on ether type as well.
Okay, I'll be sure to take a look at that. All right, if there's not more specific questions on this particular slide, then I have some questions myself, which are partially already being discussed. So anything we're missing? Well, more formalization is what I hear, and then perhaps there's more things to look at, and then the categorization. This is our first proposal of a categorization into domain properties, backbone properties, and dynamic properties. So maybe you have alternate ideas that would be very welcome. And then another, so the initial Panrg question was how are path properties defined and represented? So far we have mostly talked about, let's say we have an overview of what properties we might be looking at. We have to clarify the definition more formally, and then also the representation is interesting. So some of them are obviously, say, numeric, and we might define units, but it's probably not very interesting. But then something that I have thought about is how do we represent, for example, the access technology? Is there there is a Wi-Fi, there is a cellular, but is this just a string that is basically says it, and then, or is there some enumeration that we want? Because we have, I remember we have looked at this in tabs and we haven't found a registry that makes sense of the different access technologies that we would want here. So if you have any idea on that, and then also how do we represent that there's, for example, a specific type of device on the path, for example, the carrier grade NAT. So do we give the address of this device, or is there some like interesting question on how these things can be represented? And then finally, the working group asked for this document, and so we wanted to be brave and ask whether the working group would be interested to adopt this draft at this stage already.
So, Gary Fairhurst, I'm not talking about the adoption thing because that wasn't what came to mind, but maybe I missed it, and that's very likely. What's the motivation of collecting the data, and does that change why you're collecting it?
The motivation, well, for me, it's mostly about I am an endpoint, I have multiple paths, I want a good performance for my application, perhaps, and so that is why I want to choose between those different paths, but it doesn't have to be only performance. But yes, we didn't make that clear in the presentation, so I think also that should be more clear in the draft what exactly the motivations are, because we suppose it's like those are properties that are useful for the endpoint, and useful means that we have to motivate it, of course. And so we already got this feedback and talked a little about that, and yeah, we are going to make this clearer in the draft.
I'd like to suggest that people like IPPM have very different motivations.
Okay.
They often want to know, did my path work?
Mm-hmm.
Is it actually within the SLA I specified from the data I have?
Mm-hmm.
You actually, in what you just said, appear to have a crystal ball and be able to predict ahead how that path's going to work next time, or maybe even in a routing case, you're talking about how it will work in the next 30 seconds, so I can now make a routing decision to do something. So there is an element of predicting the future here. And if I go back to the modem slide, whoa, that's a big call. You're asking what the interference and the propagation properties will be in the future. So that's not what you learned from the data you've collected in the past. That's a different set of data. Especially when we go to places where we've got shared spectrum, and what the performance of Wi-Fi might be impacted by the performance of another waveform. So this is an area where we should also have a little bit of clarity, kind of like, are you going to use it for justifying what happened and understanding the data, SLA conformance, etc., or are you using it for the future, and how far in the future do you want to use it? I'm not asking you for the answers. I'm just saying these are the sort of things that we should decide. If you want to answer, that's okay.
I agree. Yeah, well, I'm a researcher, and I sort of try to optimize and not really predict the future, but try to find some heuristics or some algorithm that might improve things over like what they would have been otherwise.
I think you are predicting the future then.
Sorry?
I think you are trying to predict the future. Maybe you want to know how to send the next packet.
Yeah.
Okay.
But like I think what I just heard was that there's also a motivation to understand what happened before, and even that is useful. So that is actually good, and like, but also it probably makes sense to reason about these kind of things, and like what are the limitations of those metrics for whatever purpose that we're trying to use them for. So thank you for that.
That's what I was asking for.
Thank you.
I'd just like to make a comment that I think that you mentioned another question from Brian's questions draft. Teresa is trying to answer the first one, but the question about how quickly the data will be up to date is one of the later questions, which we also probably need to answer, yeah.
Sure, but some of the things you're collecting are historical information, actually. So their very nature means that they are definitely out of date, but that doesn't mean they're not valuable. So, yeah, understand that.
Wait, Brian is in queue.
Whoa.
Oh.
You just mentioned Brian.
Okay, yeah, so I'll, Brian, please.
Good morning. I heard that I was invoked. Yeah, to answer Gory's point, I think that there is indeed an element of predicting the future here, right? Like there is something along the path, so either the sender, so the transport protocol stack itself, or something in between the transport protocol stack and the rest of the network has information from the past that it uses to make a likely estimate of the future, right? Like, so in this document, we don't talk about the mechanisms by which that would happen, but we assume that those mechanisms may exist. Now, predicting the future to 100% accuracy is impossible, but is there a way that we can predict it to 90-something% that would actually give a sender enough information to make a choice? So that's what the way that I see this framework gets, yes, it predicts the future, but it doesn't predict the future, right?
All right, Giovanni, Cydian Labs, and TU Delft. So I don't want to go back to the point of definition of what is a path, but it might be useful for you in the future or whenever you update this draft to think of what is not a path. So maybe it would be interesting to look into the definition of circuit switching, like what they did in ATM, and they have a clear path. I think it was they had to establish a circuit before that, so you may want to look into that. It's an exercise to define what is not.
Okay, and I'm cutting the line after Dmitry.
Spencer Dawkins. So a couple of things I just wanted to say real quickly. One is, because we did get as far as the slide with adoption, adoption in a research group is adoption for the research group to work on it. And different research groups have a huge amount of flexibility on when they do that. What we did with the what not to do draft was basically I did 2 revisions, I think, or something like, 2 revisions just to get started and see how far that got. And basically, the thing with it being an individual draft is that Teresa can change every word in it. And the thing with it being a research group draft is that she starts having responsibility to the rest of the research group to make changes, and we start having a responsibility to help her. So be thinking in terms of when you're ready to ask for help and when you think that would be a good thing to do. I made it 2 revisions and I've asked for help. So just for perspective, I think the other thing to mention on this is that's helpful to think about. This is going to help us have a shared understanding if we ever stop talking about what not to do and start talking about what to do. That we'll be able to understand each other when we have that conversation. So it's definitely very useful for us to have this with that goal in mind among probably others.
Lars, good. So Gori made a lot of points that I was going to make, so I'm not going to repeat them, but they were all excellent. One thing, going very briefly back to the formalism, right? So if you don't know what your units are, that's a pretty good sign that your formalism isn't there, because that should just fall out of the math, right? And if it doesn't, then that tells you something.
I wasn't saying that I don't know what the units are. I was just saying, okay, we probably need to write them down, but it's not very,
my point is, if you had a formal, you didn't need to if your formalism was good enough, because they would just fall out of it, right?
All right.
But that was just a side question. So it would also be useful since it is partially about predicting the future, right? So the original charter for the ALTO working group over in the IETF, I was area director for that. So they had a very minimal goal that we worked very hard to phrase, and it's basically to do anything that's better than random in terms of, the ALTO specifically tried to give peer-to-peer clients a set of peers that they could start pulling information from them was better than what they're currently doing, which was randomly picking some from the list, right? And that turned out to be super hard. And that is a much lower bar than Brian's 90%, right? So that's just better than random.
Yeah.
So we at least have some attempts of doing something very simple that we couldn't figure out. So I'm getting a little bit depressed when I see this very complex classification of things, which could be certainly used to solve that little problem we had in ALTO that we couldn't solve, and believe that we can make sort of progress on the big overall thing where we couldn't even do it on a little thing.
But that is kind of ties in with the point I was making, that we try to make some decision that is better than what we would have done if we didn't have any knowledge, and that is how I would motivate wanting to.
The thing is, you can be worse than random if you have knowledge, and it's wrong. Right?
Okay, yeah, so, and we are also okay. In this draft, I think we should focus on motivating why these metrics would be interesting, and then leave the actual selection probably up to another draft.
I would shoot for better than random.
Cool.
Dmitry Afanasyev. I just wanted to add that one of the most important things among those attributes which I use for are their statistic properties, because in the end we are trying to predict or infer the future from the past. And essentially, many of the attributes, it's sort of stochastic process. We measure them, and they're starting to diverge. And to have to apply it in a real situation, we really need to understand what is the horizon of useful prediction. And basically, the more information we collect, the faster it becomes obsolete. So, and it's a good subject for research, I guess, as well, because it depends on environment, but in any environment, there will be useful prediction horizon, and those values will change. And if you combine more of them, if you collect more information, it probably will become obsolete faster. And that's also useful information for any control mechanism, because we want to distribute that information. And if our control cycle is basically slower than information change, it's not useful at all. So if we have temporal and stochastic characteristics of all those attributes, it will make possible to understand how many of them we can combine and still will be able to use, and when it's too much information.
Okay, thank you for that comment. I think we're having I really like this discussion. I also think it's out of scope for this particular draft, and I would really appreciate if maybe, yeah, we could talk about this on maybe.
Yeah,
perhaps
it's
another draft.
definitely out of scope of particular draft.
But I
agree.
really like it. Okay.
Okay, thank you. So I kind of getting mixed feeling from the room about adoption, and because we are running out of time, I think we can continue discussion of the list, and it looks like you definitely need have some things to add to the draft to make it more clear.
Absolutely, yeah, I think we'll have.
Thank you very much, and
another
I have a few
revision.
comments we can discuss in flight. Thank you.
Thank you.
And
Thanks.
Spencer?
I suppose one of us should change slides from time to time. So, hi, everybody. I'm Spencer, and I'm here to talk to you about what not to do. I wanted to call everybody's attention to the draft prefix, name prefix changing, because the research group adopted it. And there's also actually a name change as well. Couple things, and this is not a huge change from when I had this slide up previously, but the idea is basically we're not trying to capture every idea, but we're trying to capture every lesson that we need to learn to keep in mind when we get to what to do for path-aware networking. This is now a RG graph, so you all own it, make good choices, and please send comments on the draft contents to the mailing list. This is what the new summary of lessons learned look like. The ones in red are ones that we picked up in the last round of comments. One was providing benefits for early adopters is key. This is something we've learned on protocol design in general, but it certainly applies in path-aware networking. One comment that we got from Joe Touch was follow the money, which is very close to this topic here. We got a lot clearer statement about routers that don't process in-band hop-by-hop signals in hardware, and that being a problem for a variety of reasons. We got that because we added INSYS. We got these two because we added INSYS. So we still, so adding a couple more was still a good thing to do. A couple more contributions about things we've tried. And the third one got more complex. We had, I want to say that middle boxes needed to be able to trust in systems in order to use signals. It turns out that when we added INSYS, it made it obvious that the relationship had to be in both directions. That in order for you in order for you to not have an obstacle with trust that you had to overcome. So these are the things that are new in the -00 research draft version. I wanted to put those in front of the people. Is it possible that there are questions from the audience?
Yeah, maybe I should ask them later, but I just felt inspired to ask them now. Corey Fairhurst, by the way. So, many routers don't process in-band hop-by-hop signals in hardware. Is it really? I mean, yeah, many. Yeah, okay, so many, but some do.
Yeah.
Okay. Maybe
Well, and
the way forward is to recognize that only some will ever do and that all will never do. If that's where you're going, then I kind of agree with you.
Yeah. Thank you for the comment. I emphasize, and I don't think I say this strongly enough, this is the summary of the summary.
Yeah, yeah.
So it may be right in the draft, in the summary, but when I summarize the summary here to share with the research group, I might have done violence to it. I think what the point of this is that the processing path is not the same if you put hop-by-hop options on things. Whether that's in hardware or some mystical smoke doesn't matter, but basically this can slow down a path enough to where operators are reluctant to use the mechanism.
I heard scarier things about ECMP recently, which I didn't know about. So I will read that very carefully and try and apply what I have now discovered to that bit of text. The trust thing, each have to trust the other for middle boxes. I mean, can never trust one another. Which one do you want to go for?
This is a summary of a summary. I mean, maybe the answer is that Spencer should stop putting this up and start putting the summary up. But this is the summary, and if you look at the draft, there's one that says it has been an obstacle to deployment in the past that somebody was trying to do something that required the operator or the middle box to believe what the end system was doing. Next contribution down, there was an instance in the past where having the end system trusting the operator was the obstacle to deployment. So, like I say, you could fail in any dimension basically on this. I combined those on this. That's doing violence to, like mistakes were made in translation. So this is translating all the other contributions into Spencer, and I'm sorry for that.
But I think
yeah, you got it exactly.
Maybe you achieved your goal because what I kind of promise now is I read this carefully and I help you.
No, and thank you for that. At some point, we can talk about whether I needed a co-editor too.
Hi, Colin Perkins. I was going to make the same point that I think Gary just made for the second one of his. No, that wasn't the point I was going to make. I think middle boxes and end systems do not trust each other. They may be able to. You may be able to gain trust over time by demonstrating that what you are the information you are sharing is correct. But I think have to trust is very much not the right phrase here.
Yeah. So I may be kind of jazzed about this being a research group finally, and not yet another IETF working group trying to do stuff in 18 months when we don't know how to do it at all. But the fact that we have stories in the past in both directions, again, this is translating to Spencer, and I probably shouldn't. But this is not to say that anything that we do going forward has to have trust in both directions. It is to say that in the past, this has been a problem in both directions. It has been a problem in each of two directions. And so what are we going to do about that when we get to what to do about path-aware networking? Are you headed back to the mic home?
Yes. Hi, Colin Perkins. I would suggest that the summary of the summary may be that the lesson is that whatever we build has to work if the end systems and the middle boxes don't trust each other. Yes,
exactly. This is the lessons that we're starting with, I think, on the what to do type work. Any other questions on that slide? Nothing remotely. So this is kind of the high order bits on what I've done since the last time, which is I added a pointer to the IETF workshop report on protocol design and adoption. That's not specific to path-aware networking, nor are the other two IAB RFCs that I've added as informational references, but they're worth reading. This one is, as we started to move into the follow the money part of the conversation and incentives and things like that, the ITAT workshop was kind of was some of the topics were talking about economic incentives as well, not just technical incentives or performance incentives or something like that. I've added the contribution from INSYS and worked on things a little bit more. I'm not just adding at the bottom, I'm kind of trying to synthesize and rearrange things and stuff like that. And as we said, we had a contribution from Roland and from Martin on INSYS. So that's what's new in this version of the draft compared to the individual versions of the draft that came previously. I said please send corrections, and somebody did. So just because this is a research group draft now, you all need to know what I'm doing in your name. And Wes said, embarrassingly, the BGP specs, flow specs are not the same as RSVP flow specs. Same term is used for different things, unfortunately. So I met with Ron Bonica serendipitously on Monday, and he said what he meant basically in the original text was that the concepts were reused, not that the mechanism was reused. So some of the flow specs had the same names and represent the same kind of things, but it's not a reuse of the flow spec mechanism. So I can fix that, and I am in blue is what I'm planning to do unless somebody stops me. Would it make sense to say anything about XCP, PCN, or Connex? So high order bit is what other contributions would provide lessons that we don't already have in section 2. Those are the additional contributions that we should be soliciting. And I'm not shy. I've managed to hunt down. I think one other of these sections was a volunteer, and everybody else was caught by me from running, chasing them to do the contribution. So I'm not shy about chasing contributions. I just, like I say, need to know kind of what the research group thinks about what else matters. And the question is, what lessons would these contributions provide, whether it's one of the set of 3 or whether it's some other contribution? So I'm kind of sitting on that comment right now. Adrian, are you for me?
Sorry, I was a little lazy getting up.
Is this about the first slide?
It's about the flow spec thing. The word you're looking for RSVP is filter spec.
Ah, okay, cool. Thank you. The first RFC that I worked on was 2741, and those are 2200 RFC numbers. So there's a lot of things that happened before I got here. Miria?
Mia Kulevin. So I think the lesson of those 3 protocols is more or less a lesson of ECN, which was if the deployment story and the incentives if the deployment story is too complicated and the incentives are not clear and there's no incremental way forward, then it's hard. That might be covered by some other section, but maybe not that explicitly, I don't know. But it would make more sense to write something about the base protocol here, which is ECN.
Yeah. I think that what I'm hearing you say sounds probably most like the INSYS contribution that we just got.
Yeah.
So maybe we would, like I said, this is what the editor position is basically doing, is saying, will we learn enough about adding a contribution to change what's in the lessons learned summary?
So I had a different comment. I had the feeling that Lars was kind of keen on writing something about Alto.
No, I'm going to.
That lesson might actually be slightly different. But what Lars said earlier was like they tried to be, better than random, and even that was hard, right? So that might be slightly different lesson that you want to capture.
The fact that there are 2 past transport area directors that were responsible for Alto in the room that I can see. pick your words. And Miria is the current AD who has the pleasure of Alto. And we're all worried about path-aware networking. That kind of just tells you something, but it could be a coincidence. This one here, there was a statement of, there was an insertion on the SHM-6 discussion about, Lars, are you heading towards the microphone?
Yeah, I was just gonna, since Alto came up.
I mean, that doesn't mean we have to talk about Alto.
No, but so Alto really, so this was a pressing problem at the time, right? The peer-to-peer traffic was like really killing operator networks because it didn't go where it was supposed to go, it went like random, right? And so there was a clear incentive here, right? Both the operators were benefiting by making this information available that would hint to the clients where to connect to. And the clients were probably going to benefit because, they got onto the bigger paths right away with more capacity on them. And we still couldn't deploy this and make it work. And so the incentive for that actually were there. Otherwise, we wouldn't have chartered it. But it died for many other reasons. And also, Alto now is very different. I don't know how they got to recharter and still keep the name, but that's another story.
We'd have to come up with another mailing list.
Mia Kudevan again. So, but that was my point. I think it was not the incentives in that case. It's a different lesson we can learn from that.
Yeah.
Somebody has to write it down still.
So I think, maybe a second order pass through stuff as this draft starts maturing, and it's not on my slides because I just thought of it, but I think one of the next things that we can do is to say, if these have been obstacles to deployment for some network-aware, path-aware networking mechanisms, have they ever been overcome, and what did they look like? So I think that's a very fair observation to make. Yeah. So this one here, yeah. So basically, I got text that kind of. The text that I got from Eric Normark was accurate at the time, where it was basically talking about HTTP state and assuming that everything was running over TCP and stuff like that. This is like 10 years ago, right? That's not a meaningful explanation in 2018. As far as Spencer's concerned, what we're thinking about now is not HTTP state and file descriptors and things like that. It's talking about transport connections in general, which as long as the only thing we were doing was query response over UDP plus TCP, the only thing that mattered was TCP. But that's not where we are now. So I'm just basically up leveling that point in the draft. If that makes sense. Melinda, are you thinking? Okay. Should we wait for you to think, or you can bring me back if you need to. Cool. Thank you. That was hard thinking. I could see two rows back. This one. So there was this text in there about in the SHM-6 section, and I want to be very clear that this text, as part of that section, was something I wrote, not something that Eric Normark wrote. But basically saying, the observation was that SHM-6 got a lot of operator resistance because you had untrusted end systems that were going to be making decisions to swing traffic around from one set of paths to another. I happened to be at the NANOG session when Jeff Houston and Dave Meyer were doing their pitch to the operator community about SHM-6, and they were like, "Are you nuts?" But what they were coming from, especially at that time, was the level of security in widely deployed desktop operating systems, and basically how easy it was to roll up a 40,000 botnet, where you could say, I'm going to move all the traffic that I'm doing on this network path through this ISP, and they don't care about the path, they care about the ISP. Through this ISP, I'm going to roll it all over to that one. And it's all running at more or less full speed. And that will be, that will come as quite a surprise to the second operator who thinks he has engineered his networks well enough, except when everybody at the world shows up at full speed. So that was the concern. Okay, so I'm not, in the mind of Spencer, I'm not sure how that is different from SCTP or MPTCP, but my thing was no one cares. But that makes a larger point, which is one goal for this draft is to use it to spot proposals that might trip over known obstacles and lessons learned. But the truth is always appropriate. If that's true, my suggestion is to remove this text that I wrote from this draft, and that we'll figure out what to do with it as we start saying, as we start saying we've got research group general agreement that this stuff will be problematic. Not that you can't do it, but that it would be problematic. And then start those conversations rather than try to have those conversations in this research group about those protocols in the IETF. Does that make sense?
So I'm at a slightly different point. So with MPTCP specifically, I'm not so familiar with the discussions on Shim6, but with MPTCP, because it was using multiple paths in parallel and it was coupling the control loops. The concern that operators had is that that would allow an endpoint to do a real-time comparison of the performance it was getting. And that was worrisome because it would, it could make an operator look bad. Right? Because up until then, usually you were using one path at a time and then you maybe switched to the other path. But at that point, you didn't really know how good or bad the other one was. But this was using paths in parallel and specifically being able to tell, this one is giving me less loss and better delay, and therefore I'm going to send more traffic there. And then pretty soon you might ask yourself, why am I paying for that other link when it's consistently worse? And that was a big discussion, right? And it seems like for this particular effort in this group, right, that'll be a much more interesting discussion because you potentially, like Teresa and her colleague, had a lot of things that multipath TCP didn't even capture, right? It was purely based on TCP level information like packet losses and round trips. And already the operators were freaking out. There's this tussle here for an operator, right? How much do you want to help the endpoint make a decision when the decision might be to move away from you?
And that may actually be the point, which was that the operators could tell you were doing Shim6. It seems like they can't quite so easily tell about about some other things. But anyway, so like I say, multipath TCP is one of the working groups that Martin had when I was the area director with Martin, and now Miria has now that I'm the area director with Miria. So I have trusted them and don't really know very much about the details. So I appreciate very much your sharing that history.
Teresa Enghart, agree with what Lars just said. I find it really interesting to know about why MPTCP, what kind of resistance MPTCP met and why it still, I guess, was more successful than Shim6, I don't know. And I'm wondering what kind of draft would that be to put this lesson in? Is it a draft like what to do instead of what to not do?
Yeah, I mean, people have been trying to give me what to do information since I started the what not to do draft. So I know that there's interest in the research group to do that. And I think that will be a good thing. One of the other points now that's worth me saying out loud, when we started Panrg and when I asked about this draft and they said, that sounds like a fine idea, start typing, was basically that we had just finished a presentation on 10 years of path-aware networking stuff that didn't get deployed. So since that was true, we were focused on stuff that was like, it's not gotten deployed and insert ain't coming back, basically, to use one of the examples. Most of the stuff has got RC numbers like below 5,000. And we're not seeing it deployed, and we're thinking that that's not a good sign that it's moving forward. So, so we're writing it up. Those are the ones that we're using for lessons. At some point, coming forward, in time, I think it's definitely worth looking around at more recent stuff. And I actually have a point in there, I think it's on a later slide, but we can talk about it anyway. But anyway, so my point was I'm going to go ahead and remove this text just because I think it's starting to get to other drafts that the research group might have. And one of them is, just an analysis saying, this is what we see now. This is what we've learned from previous path-aware networking techniques. We're trying to understand how these lessons apply or don't apply in this case. And try to, like I say, we're not the police of the internet, neither is the IETF, and the IETF is really kind of bummed about that sometimes, but we sure as heck aren't. But we can, like I say, the truth is always appropriate. So, but thank you for that. So, Spencer is making the decision to add this text, and Spencer is making the decision to take away this text, and this is what you get when you have Spencer. So just to talk about where I think the goalposts are on things, I'd like for this Spencer, the editor of a research group draft, which is not Spencer's draft anymore. I'd like for this to be a document that's useful advice from Panrg to the IETF. The IETF developed the protocols that were described in this document so far that were not implemented or were implemented and not deployed. There's no reason to think that the IETF will not learn these lessons again, because some of these are, if you look at section 2, which is the summary of lessons learned, it says here's the lesson, and then here's the individual contribution that came from. Some of them have 3 or 4 lessons. Like this isn't, this is always going to be a problem when you try to do it. This is, thinking happy thoughts the next time is not going to be the win. So, so now what are you going to do? So I think that it's fair to say that the IETF is capable of learning, but the IETF is capable of repeating the same mistakes if no one points, if no one says, we've looked at this and this is the way it looks to us. I would like for this document to be useful advice to Panrg itself. So Brian has the open questions draft to guide Panrg research. This document may identify other open questions to guide Panrg, which I have not looked at all. I mean, I've read Brian's draft, but I haven't thought about at all how what we've learned so far maps onto the open questions. Have we learned things that Brian doesn't have an open question for instance? So I think that that's a useful thing for the research group to be doing with their shiny new 00 research group draft. So the question there is kind of what other guidance can we give ourselves? How are we doing on time?
You have another 12 minutes.
12 minutes reminds me of a story, but I'm not going to do that to y'all. Teresa.
Okay, I just opened the questions draft to look at it again, and 2.3 is selecting paths, I think. Not sure how exactly it was phrased in the draft, but I think that goes back to what we were discussing earlier in the path properties draft, which is actually part of probably a different draft. Oh, okay, point is we want to do path selection on the endpoint. It has limitations, as we saw. So I think learning from our mistakes is also useful input to answer question 2.3 in the questions draft.
Great, thank you so much. Thank you so much. We always try to help. So my kind of what next questions, how close am I to the end? How many more slides do I have?
I think it's 11th of 12.
Yeah, okay, cool. And that's the end. Okay, cool. So, question which we've kind of talked about so far, are there other lessons that we need to document? What other contributions do we need? Which ones from who? I just stuck comics on there because it was on the list, but like I say, I'm still interested and still happy to chase people if we think we're going to learn something that we haven't already learned in section 2. And we haven't looked at all at, or I have not looked at all at lessons from outside the IETF. And I know that there's a lot more protocol work that happens at the research level that outside the IETF than there is in. Are there things that we could learn from outside to guide us that would be helpful? I don't know, I haven't looked, but some of you all may know something about research. That was a joke. So thinking about what's next, what seems reasonable to me, we could reasonably look at the current path-aware proposals. If we think this draft is stable enough after we move things around, maybe after 0.1 of this draft, to where we can point people to this at the IETF and if there's anything going on in another research group as well. Because we're trying to say, well, the current proposals can encounter the same obstacles, why or why not? I think it's good to do that at some point. I don't know if that point is this point. Gori, do you need to? I'm not sure which bullet you're down to.
Please, talk as much as you want and I'll see what's left.
Okay. We have 12 minutes.
10
We had 12 minutes.
10 minutes.
Yeah, I know. We could reasonably compare this draft to the Panrg questions, which is kind of doing that scan and saying, are there things that we have identified as problems that we haven't told anybody that they need to be thinking about, how to work around. And we could reasonably finish this draft and publish it. IETF research groups don't have to publish RFCs, but they can publish RFCs. And that was my last slide. And I'm going to set down the clicker and let somebody ask me to pick it up. And Gori will take it away.
Okay, so Gori first. The last one, I can see reasons why we might publish it for another audience. But we have to be clear in the message we present. People keep coming to me saying we need to bring more of this stuff that's done outside of the IETF to here. And people don't always understand the culture and the things we've tried here when they bring a new piece of work here. So it would be kind of useful just to have a document that was totally informational, which said, these are the stories about what happened. I think that'd be a great thing to point people to. But if we do, then we must make it clear that some of these experiments in the IETF were good experiments to do, even though the outcome was pretty disastrous in consequences. So we need to make sure that message is very clearly conveyed, because otherwise we stop people being interested in coming here.
Yeah. It's worth me saying something as Transport Area Director for just nanoseconds. So there was a hot RFC talk on Sunday night about loops, and it doesn't matter what that is. But we talked about, like 9 people from the Transport Directorate ended up at their side meeting. And we had one of the most positive conversations I can remember having with anybody trying to bring transport work into the IETF. But I was pointing them towards this draft in its current form as possibly useful advice to them. So, we have at least one worked example that might be useful.
Teresa again. If I remember correctly, in Montreal at the last Panrg, it was pointed out that this group right now, and like who's speaking, is very transport focused, and we would like more routing people here. So sadly, I haven't gotten the opportunity to go to the Spring Working Group, for example, and invite them to come because it conflicted with Quick. So I'm wondering if there's routing people in the room and maybe they have more protocols, more lessons to teach
check
us.
that, yeah.
Cool. I'm glad you're here. So maybe there's like more lessons to teach us from, say, other layers of path awareness.
Yeah, and that's an important observation. The first time we met, I think it is true that either the first time we met or the second time we met, this both. Aaliyah is correcting me. Both of the first 2 times we met, we conflicted with, what was it, routing area or something? Yeah, routing. So basically, it's like, routing guys, please come unless you're interested in routing.
Yeah, okay. I should say it's probably my fault. We need longer conflict list for scheduling this, but I'm afraid then we'll be scheduled outside of IETF or something, because it will conflict with almost everything. But yeah, we'll try to make it better.
Yeah. Well, no, I think you already have. When we were doing you and Brian already have, when we were doing the conflict review thing, either after 102 or before 103, I think you all changed the conflict list for this to include at least some routing stuff. And this was consulting with Alvaro, who is still sitting AD and stuff like that. So it's gotten better. And I think that's why when Teresa says something, there were hands to go up. Welcome. But like I say, that's really important to keep in mind and to ask who else might need to be here. So thank you for that.
Mia Kuliman, I can just agree to Gore. I think we should publish that because we've been talking lately a lot about archival value of documents. And in this case, it's really keeping institutional memory about these things, because there are a lot of people in this room who know all the stories, and that's always why I enjoyed coming to the IETF and talking to those people. But writing it down and having an easy way to access this information in a condensed and structured way is definitely value. And I also want to agree to Gori that we maybe want to do another editorial round to get the message really right, that there was value in all those experiments, and we're just not listing only stuff that we hate or whatever. It's about the lessons learned about this.
Yeah, I think every time that we've made an editing pass over this, we've tried to make it less. Your proposal is bad and you should feel bad, and more trying to tell you it's like. And having the people who made the mistakes write the contributions, I think it's like, always remember the first contribution that went in here, Spencer wrote about Spencer's BOF, so it's like, but I think, the other thing you're saying is really important. I started at IETF 37 and I don't know the INSA story, INSERV story until I talked to Ron and Monica. It's kind of, people waved their hands about it. We don't do that anymore. I don't know why, until Ron said. Ron wrote the section.
Marco Coyo. Related to the old stories, I just wanted to point out that there is an old draft that Professor Rolahti, Sally Floyd, and I initiated in Transport Area Working Group more than 10 years back. It's titled Transport Layer Considerations for Explicit Cross-Layer Indications. So it may have some useful stuff for this draft and maybe more for the previous one. So maybe a good idea to take a look at. I don't know if it's
That would be great. Could you just send a note pointer to the list for that?
Yeah, sure.
Thank you so much. Cool. Is there anything else? So I want everybody to think happy thoughts about my lovely wife who is at home because she's doing chemo. And the next time you see her, which I hope is in Prague, you tell her, we saw Spencer stop talking before we ran out of time, because she will not believe you.
We can send you a link to this video, and I can confirm there is still 3 minutes left. So thank you very much for doing this. It's an amazing job. So, and the last presentation for today, Joe. Yeah, I'm just giving you slides. Okay, this one. So you would like to? Oh, okay. But you.
I want to read it.
Okay. Sure.
Hello. I want to talk about the problem statement of the overlay path segment forwarding. Next. So there are numbers of research and companies are trying to use the cloud route node for the best path selection to provide performance closer to the least nines. Also, we have run some experiments based on this method, and we find we can get a big chance to find a better path based on tens of cloud routers. And such approach currently become much more practical, because it is easy to build a better path via the load in the different geographic sites in the cloud, and it is inexpensive and easy to provisioning, and some cloud provider even provide the instance with enhanced network performance for sale. Here are some experiments we want to share with you. We have created around 120 virtual router globally, and this is the delay result between some cloud routers pairs. We can see. Yes, sorry. We can see some paths always give a long RTT than we expect, even they are physically close to each other, like Jakarta to this one, like Jakarta to Shenzhen, China. It always has a RTT more than 400 milliseconds, but there are, of course, some paths are pretty good, like the green ones. Next. This is the result of packet loss in the experiment. You can see some paths have high loss rate all the time. And some others, some paths are varying a lot over time. And we also figure out some problems in the overlay-based cloud network. Let's say some latency-sensitive application like video conference or gaming. Their delay needs to be shorter than like 200 milliseconds or 300 milliseconds, for example. And in the meanwhile, the end-to-end RTT is almost reached that limit. So the traditional end-to-end packet recovery mechanism is not good enough to meet the request. So better quality over best effort internet is wanted. Actually, there are some companies are doing this in the market. And also we have some potential methods to fix this, like the local retransmission over the cloud router and the FEC over single or multipath segments. So why bring it up now? Because currently the cloud internet always allows better paths to be created and selected based on the cloud router, the virtual load. And the cloud router naturally breaks paths to a multiple path segment. And this load existed or can be easily created and manipulated. And because these are VNF-based, software-based, so it is easy to add functions to this node. And the emerging technologies like virtual I/O are making forwarding more efficient. So the problem too is the inaccuracy in the sending rate decrease at the sender. Currently, the TCP sender decreases sending rate by a fixed ratio whenever a packet loss is received. TCP do things like this because it has no much information available to determine how much to decrease. Currently, the cloud router, the overlay node could provide much more congestion information to the sender, and the sender could decide if decreased sending rate is necessary and how much to decrease. The potential method, just as I said before, now, the node could provide richer congestion information to the sender. Okay.
You can see the slide in front of you.
Okay.
Question?
Yeah.
Next. Sorry, I think you have a question.
Sorry, Rick Taylor, just a clarifying question. And maybe me being stupid, probably is. What is the difference between a cloud internet and a complex transit network? I don't understand what is the difference? Can you describe a cloud internet to me from just a complex backbone internet, connected network? What makes it cloudy?
The network connected by the overlay load, we call it cloud internet. Actually, it's a cloud-based network.
Aaliyah Atlas. So cloud networks are it's a private network, right? Except people can connect in and use, and they can connect in privately, or they can connect in via VPNs or whatever to get to their private cloud. Then inside the cloud provider, they have their own connectivity to go between different geographical regions. What he's talking about is if you want to buy that, you get private transit through, but these cloud providers in general are not internet transit providers, which has, for instance, regulatory requirements and legal issues associated with it. So they're not providing transit, but it turns out that if you send traffic in at point A, stick it in a tunnel and get it out at point B and then send it to your own stuff, it smells a lot like it.
Thank you.
I am, of course, delighted to be welcomed.
You're always welcome.
Thanks, Jen.
Hi, Colin Pickens. Is there also an assumption that you're doing processing in the clouds as well as just routing?
Sorry?
Is there also an assumption that you are doing processing in the clouds, or is it just being used for routing?
Processing or routing?
Is there an assumption that you are using the clouds to do complex processing on the packets, using some of the compute infrastructure that is in the clouds, or are you just using them as a routing overlay and just essentially running a software router in a cloud-based node? I mean, I think it's just using it as a routing node.
Routing and some tunnel encapsulating and
So you're encapsulating the packets and tunneling them, but you're not doing any other complex processing.
Rick Taylor again, just to reply, what I understood from Aaliyah was you're literally just using their infrastructure. It's the fact that and their computers required to push the packets around, but it's the fact that they're not a national ISP or whatever, but guess what? They've got the connectivity.
Oh, yeah, clearly they have connectivity, and you're just using it as a routing overlay rather than as a caching overlay or a compute processing overlay.
I'm on the right slide.
Yeah, next
one.
Next.
You can see which one I'm in front of.
Yeah, right. So we want to take this opportunity to do the loops, localized optimization on path segment. Refer to this picture. Below the end-to-end path, we have multiple overlaid path segment between overlay nodes, the ON, and we can try to solve the problems mentioned before, like the slow recovery over long haul and the inaccuracy in sending rate decrease at the sender. And also this solution has some other issues should be addressed, like the impairment, temporary outage of the virtual hop, and limited capacity of the ON's virtual nodes.
Adrian, you have a question?
Hi, Adrian Farrell. On that previous slide, I want to pick again at the definition of the word path, because when we have a path segment in the network layer, this is a different path type than a path in the transport layer. And I would have thought that if you want to talk about transport paths, the path segment needs to pop up into the transport layer. I may be being really pedantic, but so what your picture is fine, the labels on your picture upset me. Yes, Amelia is just saying, should we maybe call the things you have got as path segments, maybe we should call them tunnels and...
Tunnel, yeah.
Castro, and of course, another question is how many instances of which layer do we have in this picture? So, of course, everything that's blue is a little transporty here as well.
Do you want me to switch to the next one?
So the elements of solution, we think there are three key elements to address the problems: local recovery, congestion control interaction, and traffic splitting recombine. For the local recovery, we can do it based on the entire tunnel, which aggregates the flows together. And we can do the loss detection, retransmission, and RTT measurement between the ONs, between the nodes. And also during the local recovery, we need to pay attention on how to limit the retransmission attempts and how to control the FEC replication intensity. For the congestion control interaction, we definitely don't want to get competing between the local retransmission and the E2E congestion. We may, but we can do it. We may export some appreciate congestion control signal from the loops to the E2E transport, and we may support the ECN too.
So I gave you way more of my opinion than you probably wanted to hear during the site meeting. So all I'm going to repeat is that for this particular group, right? You're giving the same presentation you gave at the site meeting, which is, I think, way too broad. I think the key bit is this signaling, or at least sort of the conversation of this thing with the transport. That might be the path-aware bit that you might want to get feedback on here.
Sorry, Rick Taylor again. I'm just trying to work out what's going on here, and I'm a bit slower than everyone else in the room, I think. So this is, as I understand it, you're trying to say, I don't quite get what loops is. It's a signaling protocol between your tunnels, so that although your packets are living within a tunnel, it's to signal the information by the fact that it's actually an overlay on top of a much more complex underlay. Or am I miles off?
It's a overlay-based mechanism.
Yeah.
It encapsulates all the original payload to the tunnel.
Yeah.
Then it do the per hop mechanism instead of the end-to-end, like TCP.
Underlay or overlay hop?
Overlay hop.
Right. Thank you.
Carsten, yes. So I think what he has tried to do is describe the whole thing, but the whole thing includes components that somebody has to do, but are not really part of what this is trying to do. So somebody has to buy those cloud routers or pay for them and set up paths and maybe even measure them, put a controller somewhere who has a global overview over the health of everything and all that stuff. That is already happening. And if you can go to the previous slide, thank you. So the question is simply, is there something that can be run between ON1 and ON2, and between ON2 and ON3, and between the ingress and the egress, that might be used to improve what we have, a transporty thing. Or a link layer thing, whatever you think about it, but not a network thing, but a thing that actually looks at packets and makes sure they get there. So if something is lost, you recover them. And this is what loops is about. So it's not trying to solve the problem, how do I get the best path I need and so on. Somebody's already solved that. It's just now that I have those paths, how do I get local transport, the lower blue things running? And the other question, of course, is how do I avoid that fighting against the upper layer transport, but exactly the inverse, how do I get these two transports to live forever in harmony?
Harmony is good.
Array Atlas, yeah, so the feedback loops between the lower layer and the upper layer there are, certainly that's an interesting question. you're talking about the path between, say, ON1 and ON3 as if it's, because it's a tunnel, it's taking a single path through the network. And I think that's not a very, I mean, is that your assumption? Because it doesn't make sense to me.
Sorry.
You're talking about the traffic that takes the tunnel between ON1 and ON3, for instance, or ON2 in this case, as if it is a single path, as if it's taking a single path through the underlay. And I don't think that's an accurate assumption.
It's also not an important assumption.
Sorry?
It's also not an important assumption. The important thing is that the packets get from ON1 to ON2.
Right, but if you're trying to measure things like RTT or probe the health of the tunnel, then it's a much more exciting problem.
Yeah, but that's a problem that every transport has.
Sure.
Yeah, so we are running slightly over time, so I'm cutting the line after Goris.
Yeah, Spencer Dawkins, so I'll just be real quick and say, we're, focusing on asking the group and everybody to focus on the path parts of this, because we can screw up transport on a single path all by itself. But especially the thing that you had on the other slide that you've been showing that's got the path splitting and traffic recombining and stuff like that at the bottom. And then probably starting to get into the number 2, things like that. But like I say, is be thinking, whatever anybody else is, can help you with, definitely the Path-Aware Networking research group has got to be thinking about those kinds of things because nobody else is thinking about them. So thank you for bringing the work here.
Thank you.
Next.
This one.
So you have -1 minute. Minus.
Okay, so the future work. So I will finish it soon. So we think there are some work items that may highly relevant to this research group, like the traffic splitting and the multipath utilization. So we want to collect your feedbacks, and we also have a live test bed running in the internet. So if you are interested in it, please come to me. Thank you.
Okay. Thank you. And nobody moves. Please raise your hand if you have not signed blue sheet. Okay, good. I'll come to you. And thank you guys. See you in Prague. Yes. I'm doing nice. Okay.